Welcome to your Unit 9 review. It will be Mr. Zazowski, obviously, taking you through our coordinate geometry practice test here. So taking a look, remember the formulas you're going to need for this practice test are, first of all, the slope formula. All right, and M, like slopes on a mountain when you're skiing there. Y2 like minus Y1 over X2 minus X1, or rise over run, however you want to remember that one. We have our midpoint formula, which is X2 plus X1 over 2. And y2 plus y1 over 2. Remember, we need parentheses around this because it is a point. All right. And the last one is the distance formula, which is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. All right. So we went over the first one in class, but we are going to pull from this distance formula here. And so we're going to write down our formula first. So distance equals, we know it's distance because it says the coordinates of the endpoints are given. All right. We want to find the length. This is the key word for us that tells us we're doing distance. And we want to do simplest radical form as well. Okay, so no decimals. So we're going to do our distance formula. So remember, it's x2 minus x1 squared plus y2 minus y1 squared. And remember, when we look at the points, we're going to think about the first point being x1 and y1, and the second point being x2 and y2. All right. So we're going to plug in distance equals square root, okay? So we're plugging in x2, second point x coordinate, so 2 minus negative 4. And then when we change our double negative to a positive, we're going to get plus 2 plus 4. That's going to be 6. And then we have 5 minus 3, which gives us 2. Now, positive or negative, when you square these, they're always positive numbers that you're going to be adding together. So if this was negative 6 squared, don't put negative 36, okay? So we know we're going to get 2 plus 4 squared, which is 6 squared, so that's 36. 5 minus 3 is 2, and 2 squared is 4, and that gives us an answer of the square root, of 40. Now, when we do simplest radical form, we're going to bust out our calculator. We're going to go to the calculator page. If you don't remember, we're going to go to menu, and then number, so choice 2. And then factor, choice 3, or just type in the letters factor with parentheses here. And we're going to type in the 40, not square root 40, just 40, and it's going to give us the prime factor. So there's 3 2's and a 5. So this is going to equal square root, 3 2's, put a times in between all of them and a 5. We're going to take our set of 2's, which is really 4. We're going to bring 1 2 out because the square root of 4 is 2. And we get a final answer of 2 square root of 2 times 5, which is 10. And that is our simplest radical form. What I'll do is do the odd numbers first, and then I'll send you another video with the evens in there. Remember, extra credit if you do both. All right. So number 3, just midpoint. Okay. So remember, if you remember the midpoint formula, that's x2 plus x1 over 2, and then y2 plus y1 over 2. And keep in mind, we need parentheses because this is a point. So if we look at the first point, we can call that x1, y1. And then our second point is x2, y2. Now, you got to be careful because we're already going to make a mistake here. If we plug this into the formula, okay, we would be doing this wrong. And here's why. Okay, we're starting at point A, and we're going to point B. That's segment AB. M is the midpoint, so M is in the middle. If we were to use these 2 points, okay, A and then M, we would actually locate the middle of AM, which is here. And that's not what we want. We don't want the middle of AM. We want the 1/4 point. We want to get B. So if you remember, we're going to choose a little different method for this, and this is our leapfrog method, okay? We're going to say we're going to start at point A, okay? And we can even use this line that we just drew over here, all right, minus the green dot there. Let's get rid of that, okay? We're going to start at A, all right? Actually, we'll leave it right here. We're going to start at A, and A has the coordinates of negative 3, 6. Okay, we want to move over to M, which is the points negative 5, 2, and then we want to move over to B, okay, which we don't know the coordinates of. So what we want to ask ourselves is, how do we get, okay, from the x-coordinate, -3 to -5, and then we're going to do that same move again to get to the next coordinate. So -3 minus 5, well, we just have to subtract 2 or add -2 to that. So if we do that again, -5, take away 2 more, we'll be at -7. Okay, and likewise, all right, and we'll zoom in a little bit here to make this a little easier to see, hopefully. Likewise, if we take our y-coordinate and say we're going to go from 6 to 2, okay, we're going to take away 4, then we just have to take away 4 more, all right, to get to b, and 2 take away 4, that's -2. So our answer here, our answer for point B, and then we put our parentheses, would be -7, -2. All right. Now you could use an equation like this to do this. You could say that, like, for example, x2 plus -3 divided by 2 is equal to -5. So notice that point B, I'm going to say it's going to have the coordinates x1, y1, and then this would be my 2's. I'm just plugging these in here. So all you have to do essentially now is cross multiply, okay? So x2 minus 3 would equal -10, and then I would just add 3 to both sides to solve this equation for this x2, and notice we get -7. So this is algebraically, this is just a little more visual and kind of easier way where you have to do all the solving. So feel free to pick either one and run with it. All right, number 5 we talked about in class if you were in first or fourth period, but if not, just in case, just a reminder, okay, if we have a graph, there's my graph, and I want to draw a line that's parallel to the y-axis, I have to draw a line that's going up and down and through the x-axis. Any lines that cross through the x-axis and not the y-axis, these are vertical lines, follow the equation of x equals whatever number this is, okay? So for example, if we're crossing through, I don't know, we'll call this 1, 2, 3, this would be x equals 3, okay? If we draw a horizontal line that crosses through the y-axis, this is going to have a y equals, okay, to it. So same thing here. In this case, that would be y equals 4, okay? So if we're parallel to the y-axis, it's got to be vertical and be x equals, and so choice 2 would be our answer. All right, heading over to number 7, which equation represents a line that's parallel. So remember, parallel, we're thinking automatically that we want the same slope, okay, to the line who's this equation. So we can see these slopes nice and easy. And when we use our y equals mx plus b form, we know that the slope is always right in front of the x coordinate. So we can get the slopes just by looking here because these are already in y equals mx plus b form. All right. In our other form of a line, right, remember that the slope is going to show up in front of the parentheses here. So you can kind of choose either method. If it's not in either of these forms, we're going to try to solve for y and get it in this form if we can. So just like here, I would want to move that 3x to the other side first. And because we want to have mx plus b, we're going to put the -3x in front of that +7. We're going to bring down that -2y, and we're going to finish this off by dividing by -2. And we remember, hopefully, that a negative divided by a negative is a positive. So we get 3 over 2x, and then -7 over 2, or 3.5. Now, if we're parallel, we can't have the same y-intercept. So they could perhaps, for example, get tricky, and they could say that this answer, let's say that this is actually +3 over 2, and this has 7 over 2 as the y-intercept. We would not want to pick this one because not only does it have the same slope as our line, it also has the same y-intercept, which means they're overlapping, and they're not, this would also have to be minus, they're not parallel, okay? So we would want to pick choice 3 here because choice 3 is the same slope and different y-intercepts. Hope that makes sense. All right, hopping on to number 9. Given line MN with point M and N shown, write an equation line that passes through the point P161 and is parallel to MN. So Two things. Number one, remember that if I want to write the equation of a line and it doesn't tell me the form, we're going to default to writing it in point slope form, okay? And even if it wants slope intercept, we're going to start here. So two things I need. I need the point. Now we have the point. It has to go through point P. So we know that P is x1, y1. So I can already start my equation as y minus the y coordinate 1 is equal to some number m, which we'll get to, and then x minus 6. So if this is multiple choice, I can probably eliminate some answers that don't follow this format, okay? The other thing we need to do is you need to get the slope. Now, two options. All right, option number one, we have our slope formula, which is y2 minus y1 over x2 minus x1, and we can just plug in, so second point y coordinate, well, that's -5. I immediately write the minus, and now I go look up here and see that it's 1. This will help you catch those double negatives. x2, second point x coordinate, is 3 minus, and now look at, now I got to bring the -6 down, and remember that this is going to change to plus a positive. So we're going to get an answer of -6 over 9, okay, which we could divide out 3 from each of these, and we would get a slope of -2/3. Now, if you are counting on the graph, we want to remember that slope is just rise over run. And so if I just draw a line going down from M over to N, okay, a little bit too far in that one, over to N, you can see that I'm going down 1, 2, 3, 4, 5, 6. There's my -6 because I'm moving down. Okay, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, over 9. And so my slope is going to be the same thing, -6 over 9. And hey, look at that. That's what we got right there. Okay, we already know that that is -2/3. And because we want to be parallel, we know that our slopes are going to be the same. So we're just going to plug -2/3, and there is my answer. Okay? If you needed to, you could distribute the -2/3 through. Okay, this would be in slope intercept form. We would get y minus 1 is equal to -2/3. And then we just distribute through. So it's really like -2 times -6 is 12 over 3, which turns into 4. Okay, and you have a calculator. You could type it in here if you need to. 12 over 3. So that's y minus 1 equals -2/3. Oh, don't forget your x. Plus 4. And then I add 1 to both sides to get y by itself. And this is my slope-intercept form, okay? You don't need to do this for this question. You don't need it. But it's just, how do you get here? And you know what? I totally forgot to include the x with here as well. 2/3, -2/3, x plus 5. There we go. All right. Number 11. The slope of QR is x minus 1 equals 4, and the slope of ST is 8. If these lines are perpendicular, remember, perpendicular lines have negative or opposite reciprocal slopes. All right? So determine and state the value of x. So we know that our two slopes are not the same, but they're equal if we take the negative reciprocal of one of these two things. So what we're going to say is that this slope x minus 1 over 4, okay, is going to be equal to the negative reciprocal of 8/3. So we wrote negative slopes. This should be negative reciprocals. I'm talking and writing at the same time. So that means if I take 8/3 and I do the negative reciprocal, we flip it upside down and we change the sign. So it started positive, it ends negative, okay? Now I'm going to come over here. I'm going to write -3 over 8, and all I'm going to do is solve. And remember, we can just cross multiply to solve. So we're going to get -12 is equal to, remember we have to distribute through here, 8 times x minus 1, and I get 8x minus 8 equals -12. We're going to add 8 to both sides. We're going to get 8x is equal to, and it doesn't really matter which one of these you make negative, so just be aware. We're going to get negative 4, and then we'll divide by 8, and x is equal to negative 1/2. All right? Okay. On to the next one here. So we're going to number 13. Find an equation of a line. So remember, equation of a line, all right, passing through the points 6, 5, and perpendicular to the line whose equation is given. Now, because it just says find an equation of a line and it doesn't say what form, we're defaulting over to point slope form, okay? Also, we're going to use this line because we don't have a y-intercept. We don't know what the y-intercept is. All right, so now, first things first, we have to figure out the slope of this line, and then we need the perpendicular slope, okay? We already know it's going to go through this point, though. This point, don't cross it out, highlight it. All right, so we already know that x1 is 6 and y1 is 5. So we already can write the format of our equation, y minus y1, don't pick the 6, 5 is equal to some number, whatever the slope is, and x minus 6. We already know that that's going to be the setup. So now we just have to get this in y equals mx plus b form so we can identify the slope. Okay, so first things first, we have to get this by itself. So we're going to undo the subtraction, the addition by subtracting. We're going to get 2y is equal to, remember, we end up with mx plus b. So we're going to put the x term in front. So negative 3x plus 6. And then we'll divide, everything gets some love here. So divide by negative 2. And y equals negative 3 over 2x. And then we have plus 3. Now remember, perpendicular, key thing, opposite reciprocal, okay? Got to be the opposite reciprocal. So the slope of this line is negative 3 over 2, but that means the opposite reciprocal slope, we do that little m with a perpendicular sign, okay, is positive 2/3. Flip it, change the sign. So we just plug the 2/3 right here, and there's my answer. Remember, you could distribute if you need slope-intercept form, okay? So if you distribute through, you're going to get 12 over 3 again, which is 4, and then you add that over, okay? So if you needed to, right, distribute through, we'll get y minus 5 equals 2/3 x, and then 12 divided by 3 is 4, and then we just add the 5 over when we're done, and y equals 2/3 x plus 1. That would be slope-intercept, point slope. If it doesn't say either of these answers is fine, you don't have to give me both. Okay? On to number 15. A student wrote the following equations. Are they parallel, the same line, perpendicular, or intersecting but not perpendicular? This just means anything else, okay? So we know parallel means the same slope, right? But they have different y-intercepts. We'll just say different b, okay? The different y-intercept. The same line means they have the same slope, m, and they have the same b, okay? Same slope and y-intercept. And if they're perpendicular, that means that their slopes, okay, are opposite reciprocals. Intersecting but not perpendicular is anything else. Any other equation where you look at the slopes, they're not the same, they're not opposite reciprocals, okay? That's what we're filling in. So let's take the first line. 3y plus 6 equals 2x. Remember, we're aiming for the y equals mx plus b form, so we can easily tell what m is. So first we're going to subtract the 6 from both sides. We get 3y is equal to, remember, put the x in front, and then divide out by 3. And we get y equals 2/3 times x minus 6. I always put the x afterwards so it's easy to see the slope. And then the next one, we have 2y minus 3x is equal to 6. So we'll add that 3x to both sides. 2y is equal to 3x plus 6. and then we'll divide out a 2. And so y equals 3 over 2x plus 6. And we can see the slopes. So we have 2/3 and positive 3 over 2. They are reciprocals, right? But they're not negative reciprocals. They're not opposite reciprocals. So we know that the choice we're going to make here is 4, okay? Because they are reciprocals, but they're not opposite reciprocals. All right, on to number 17. What is the equation of the perpendicular bisector? So remember, we talked about 4 things we need. We need the slope. We need the perpendicular slope. We need the midpoint. And the last thing we need is we need our equation. All right, and keep in mind, we're putting the perpendicular slope and we're putting the midpoint in for x1 and y1 here, okay? So use the perpendicular slope, not the original slope. So step 1, let's go find the slope. Now we're going to use our formula y2 minus y1 over x2 minus x1. We're going to pick our points. So the first point we're going to designate x1, y1, second point x2, y2. All right, y2, second point x coordinate, -7, minus the first 5 over second x5 minus -11. All right, remember that double negative becomes positive. So we get -12 over 16. And we can take a 4 out of each, and we get -3/4. If you don't remember how to do that, you can always type it into your calculator and hit enter, and the calculator will reduce this for you automatically, okay? All right, now that's the slope. We want the perpendicular slope, okay? So number 2, the perpendicular slope is the opposite reciprocal. So flip the fraction over, 4/3. This was negative, ours stays positive. All right, third thing we need is the midpoint. Remember, midpoint is the average. Add the x's, divide by 2. Add the y's, divide by 2. Gotta remember parentheses though. All right, so y2, -7, plus y1 is 5. That's -2 divided by 2, which is -1. And then I have the x2, which is 5 plus -11. That's -6 divided by 2, and that's -3. So there's my midpoint. And now I'm going to go plug in my perpendicular slope and my 2 coordinates for the midpoint into my equation. So step 4. All right, let's go some purple. Okay, we're going to take our point slope form, because it doesn't tell us what form to use. We need an equals here. And just an x. I'm used to using x2 everywhere here. All right, so y, it's supposed to be minus. This is -1. So remember, we plug a -1 in, that really turns into a positive, okay? +1 equals our slope, which remember the perpendicular slope is 4/3. Don't use the original one. And then it's x minus, right? Oh, we made a mistake already. Look what we did. The y coordinate's -3. We put the x coordinate there. Man, this is supposed to be +3. And maybe you were looking at it at home going, he did it again. You put in the wrong spot, right? And then x plus 1. And there is our answer. And that's it. All right. And then we got number 19. So number 19 and 18 are kind of the same thing. You'll have a sheet of extra sheet of graphs, so you'll be able to kind of use this one on your own. But we're going to be talking about how to find the perimeter. Now, options. Number 1, we know the perimeter means to add all sides. But in this case, it also means we need to take the distance. It's the sum of the distances, okay, of each line segment. And then we're going to add them together. Added together. Now, because we're using a graph, we're going to do this a little differently. So we could use our distance formula and do this 3 times. Okay? x2 minus x1 squared. I'm just going to clean that up just a second. Minus x1 squared plus y2 minus y1 squared. But because we're on a graph, okay, we can also think about this line, this distance, the length of this line, as being the side that's created when you draw in the rise and the run that creates this right triangle. So if I consider this to be A, B, and C in this right triangle, this distance is also the same as the length of this segment, which is the hypotenuse of the triangle. So we can literally just count, right? This has a length of 3. This has a length of 2, 4, 6, 8, 10, and 11. All right? And we can see from D to N, right? We go from 10 to negative 1. That's 11 spaces. That's 10 down and then 1 extra one. So we're going to do distance, okay? And what I'm going to write down in the corner is I'm going to write down 2 letters, DN, and that indicates what line segment I'm doing. I have 3 of these, okay? And so all I'm going to do is use Pythagorean theorem. A squared plus B squared equals C squared. And I'm going to plug these numbers in. 3 squared plus 11 squared is equal to C squared. And I'm going to square these numbers. That's 9 and 121. So this is 130. And this is equal to C. Now it says, round your answer to the nearest whole unit. So I don't need to do any simplest radical form here. Okay? Don't need to do any simplest radical form. Don't forget your squared. And then we square root to get the square root of 130 equal to C. Okay, we're going to do it again, though. We're going to do the same thing here. So if you look at, all I'm really doing is I'm going to end up drawing a rectangle, a box, around the triangle that goes through each of the vertices here, okay? And so you can count this one now. So it's 3, 4, 5, 6, 7, 8, 9. And then 2, 4, 6, 7. All right? So here we go. We're going to do the same thing. This time we're going to switch colors. So we're going to say the distance. And here we're going from N to A, or from A to N. And we're going to do Pythagorean theorem again. A squared plus B squared equals C squared. So remember, it's 9 squared plus 7 squared. And that's 81 plus 49. So that's a 0. Carry the 1. That's 12. That's 30. So also 130. And then we can square root. And by the way, now we know that if these two distances are the same, that these two sides are actually equal. And this is actually isosceles because the distances are equal. We'll talk about that a little bit in a later unit here. All right? And then the last one we're going to do is we are going to do the distance from D to A. Now, it seems like we have to count this whole thing, but we really don't. Because we already know this is 3, and that's 9. So that makes this whole thing 12, right? And we know that this was 11, and that's 7. So that makes this 4. And you could count that boxes, though. And so now we're going to do the distance from D to A. And so same thing. A squared plus B squared is C squared. Try this one on your own and see what you can come up with. And hopefully we got 144 and 16, which gives us 160. And so we know the length of this side is now the square root of 160. So we have the square root of 160 for the length of DA. All right, we have the square root of 130 for the length of NA. And we also have the square root of 130 for the length of DN. So we're just going to add those together. Okay, so the perimeter is equal to the square root of 130 plus the square root of 130 plus the square root of 160. We'll grab our calculator, we'll type all those in, hit enter, and it's 35.452, or 3, okay? And it says nearest whole unit, so we're only looking at the number that immediately follows the whole numbers here, which is a 4, and so we're going to keep this as 35. And this would just be units. You don't have to put U, but if there was a unit, we want to put it down. And that's it for number 19. All right, that is it for the odds. Hopefully that helps if you got stuck. All right, and I'll send a video for the evens in just a little bit.